the technology came out in the late 80s. Somebody earlier today asked me, are you following this technology? And my response was, well, when I was in engineering school at University of Utah, in 1989, I had my first opportunity to use a stereolithography machine and design some product. And so yes, ever since 1989, I've been very interested in this technology and very active in seeing where it's going, and we've looked at it quite a few times in our organization to do it. What I kind of want to do is talk about why we should embrace this idea, and then kind of I have to, I'm being sponsored by Hangar, so I've got to make sure I explain who Hangar is, and then I want to kind of get into some of the current technology that there is available for upper limb prosthetics, and then also talk a little bit about the obstacles that are faced for us to get this integrated into the system, and then the future of where it goes. I'm going to start out with a couple quotes, and then I'm going to end with a quote. I can honestly say I never thought I would quote Bill Clinton, but he really said something great. He said the price of doing the same old thing is far higher than the price of change. I think that's a pretty profound statement. The best way to predict the future is to create it. So you create the future, you don't wait for it to happen. So I'll tell you a little bit about Hangar Clinic. Hangar Clinic started in 1861, I believe it was, the first amputee from the Civil War. It has evolved through those years. This is an older picture, not obviously from 1861, but we have near 800 clinical facilities across the country, and we see over a million patient visits to those facilities every year. So we have a lot of people walking through our doors every year that we get to take care of, and I'll tell John, welcome to our world, because for years we've been seeing those smiles and those aha moments, and it's amazing. And that's what has driven my life. Some of the other fun things that we get to be involved in are we are sponsors for things like Camp No Limits. And this is the reason I wanted to show this, is it's a very good opportunity, mainly for younger kids to go to these camps. And they go with other people that have limb deficiencies. And they rappel, they water ski, they hike, they do whatever it takes. It doesn't matter what their limitation is, they help them do that. And we're a proud sponsor of that organization, and they have, I think, 10 different locations across the country that they do these camps at. So I just thought I'd throw that out for you. We also give back to the community in a lot of ways. Within months after the horrible earthquake in Haiti, we set up a clinic at Albert Schweitzer Hospital, and have treated hundreds of Haitians that needed our care. They just didn't have anything. So we have been supporting that clinic, and then we've taught the local people how to do that. So we've trained them how to make prostheses and do it. Let me talk a little bit about a goal. Whenever we provide a device, the most important thing is we need to match what the function needs are to what the individual goals are. So if it's the Medal of Honor winner that wants to shake the president's hand, I need to do that. If it's a young man that had a horrible accident and had to cut his own arm off, who later wrote a book about it, and then it became an Oscar-nominated movie, we have to come up with a solution for him. It could be any one of your family members that they have individual goals. Every person is different. They all want something different. It could be the mother that just wants to look pretty and go out and socialize. The soldier coming back from the war. And last but not least, it could be the dolphin. Yes, we made the tail for the dolphin. I hate to say it, Morgan Freeman didn't actually do the tail for the dolphin. So as far as prosthetic options currently for upper extremity prosthetics, there really are 6 major options that we currently think about. And I'm pretty sure that people are going to say, well, why isn't 3D printed stuff listed there? The reality is it is. It's one of these options. Could be some of those options. It could be in multiple categories, because the options really are, there's a lot of people that it's not the most beneficial for them to wear a prosthesis, depending upon their amputation level, their functional level, the sensation they have. There's some people that truly are better off not wearing a prosthesis. It's getting more rare all the time, but that is the case. We have to consider that. There's oppositional or passive type devices, where they're just pre-positioned and then they're used by manually. There's cable-driven or body-powered. So you've already seen a couple of the categories that the 3D printed stuff goes into, in the oppositional and the cable-driven. There's electric, and they can be controlled from many different ways, or hybrid systems. A hybrid system basically combines different technology. It might combine some of the body-powered stuff and some of the electric stuff, and to find out what the right thing is. And one of the most exciting categories for me is the adaptive or activity-specific designs, because that's when the fun really begins, is when you can get somebody to do something that they really want to do, then all of the other things that they kind of need to do, they learn how to use the prosthesis for. The most important thing really is how it interfaces with that person. And that's what the prosthetists spend their time doing. And we spend a lot of time working on, is it comfortable for that person? What kind of skin are we dealing with? What kind of functional requirements do we have? What's the dynamic loading going to be? How are they going to use it? What range of motion do they need to have? How's it going to suspend and hold on to their body? So those are all the things. And keep in mind, almost every amputation is unique in some way. And every patient is very unique. They all want something different, so you have to really focus on it. One of the things we find is people's expectation and reality isn't the same. And this is a video that I saw quite a few years ago, and I thought, you know what, I would love it if we could make a prosthetic device like that. My guess is we will. It is heading that direction. And using things like 3D printing will help us accelerate that process. We're not quite there yet, but I think it is. Yes, I would definitely think that'd be pretty cool. What role has 3D printing already played in our industry? Okay, every product that has come out, especially all the upper extremity ones, in the last decade or more, has used some part of it as a 3D printing process, either to design it or even in the early prototypes, or even in some of the production models, some of the components inside of it may be 3D printed, because it's a more efficient way to replace that manufacturing. It's used for specialty applications. In our organization, we use it to produce burn masks. Burn masks are used, a lot of people see the athletes that break the nose or whatever, and then they get the little clear plastic mask to protect them from further injury. Burn masks are used to compress burn scar tissue to help soften that up. And my video is supposed to keep running real well. So first thing we do is we take and use a laser scanner, 3D laser scanner, to scan the image of that person's face. That's the image on the right-hand side there. And then the image that was rotating, let's see if I can get it to go again, there we go, is the model that's going to that 3D printer. So that, because it's a complex geometry, we've found that it's much more efficient for our fabrication and more precise to use that method. Then we use a vacuum-formed thermoplastic technique to make those masks. There's a orthosis that some people might be familiar with called the Rex. Okay, it's the Wilmington, robotic exoskeleton something. And it's sold in like small, medium, and large sizes and so forth. But the reality is, it isn't sold in all the sizes it needs to be. And for some of these little kids that have a disorder called arthrogryposis, for them to be able to reach out in space, hold that limb in space and stuff is very, very difficult. if they can even do it at all. And this device basically helps them do that. And honestly, I wish I would have had the audio going, because this little girl's singing a song. You can see how happy she is about the whole thing. But it allows her to reach out in positions, basically has some rubber bands across the joints and stuff. But as she gets older, she can go into some of those production models. So that's something that's used quite a bit now. So we mentioned challenges. Guess what? Challenges are just like a hurdle. You just got to figure out how fast you got to go, how high you have to jump, and what you have to do to get over those challenges. So some of the challenges we are faced are regulatory issues, and that is a real challenge. They have, most of the time, most of these devices were considered a Class 1 medical device. Recently, all the new products that have been going through the FDA has been required to go through a Class 2 medical device. So that could be a huge challenge to deal with this. There's licensures and certification issues even for the practitioners, the prosthetists that could be involved. There's potential intellectual property issues. There's people that have designed stuff in the past that we need to make sure that, they're not going to come after an individual, but if a corporation or something picks up that design and starts making it, we'd have to get all our ducks in a row to make sure that that isn't a problem. A huge one is product liability. And people say, what do you mean product liability? And okay, I'll give you an example. And this is probably the most horrific example I could give you. Imagine if I went as a representative of Hangar Clinic, I fit somebody with 2 of these hands. And God forbid something happens, even if it wasn't a failure with the device. They're driving their car, something happens, they wreck their car, run into instead of, everybody says, oh, they hit a school bus. No, they actually hit the kids waiting at the school bus stop. That might seem far-fetched, but guess what? Over my career, I have experienced where people have been wearing prosthetic devices, have had accidents in motor vehicles, and guess what? They sue the person that fit it, they sue the manufacturer that made it, and they go after whatever the deepest pocket is. And so there is an issue with product liability that needs to be considered as part of this. Really what would need to happen is there need to be, for it to be integrated into prosthetic clinics, there would have to be a supplier that was set up that could print it to certain specifications, assemble it to certain specifications. We'd need to test it. We'd want to make sure all the regulatory affairs are satisfied, and that we can make sure that there's product liability insurance and all the things in place. But that can happen. Keep in mind, it's how high you jump and how fast you run and all the things you need to do. It's not insurmountable. It's not a hurdle that we need to deal with. I don't know if you guys have seen this picture. It's from the University of Nottingham. It's a pretty cool design. They integrate the sensor technology into the printing, and it's a pretty neat stuff. But what can it really do? Reduce the healthcare cost. It is our obligation. I don't care if you're a healthcare provider, a user, a designer, an engineer, a therapist, or whatever. The healthcare system is not going to fix itself. The only way it's going to be fixed is if all of us do something to help reduce those costs. Access to worldwide populations, as mentioned. There's a lot of people that could use this. Believe me, when we did that project in Haiti, I wish we would have had this, because we didn't have a good alternative and had to choose, with the exception of people that were missing both their arms or somebody that was missing an arm and a leg. We had to choose not to fit unilateral upper extremity amputees down there, just because of the resources that we had and what was available to fit them with. He mentioned the last talk, we have to think in designs in a different way. We can't limit ourselves to what the current manufacturing processes are going to limit us to. And I think one of the areas that this actually excites me the most is it allows for sizing and customization that we've never been able to do. We do a very good job of customizing the fit of a prosthesis, but we're still limited to the sizes that come out of the catalog. And so I think, especially for the pediatric population, because the pediatric population right now, in my opinion, is completely underserved in the traditional prosthetic world, because we're very limited in what options that we have to provide them. And to me, I'm excited to see these kids running around, because guess what? As things move forward, they're going to grow, and then they're going to grow into some of those sizes for the other technologies. They're going to say, you know what? I want to do gymnastics. I want to tumble. Well, then come see us, and we'll make you an arm to tumble, or you know, whatever it is. I want to go swimming, or you know, whatever. So we can definitely help with those applications. We've been involved in some stuff, everything from high tech to low tech, and this is a project we got involved in a couple years ago that I wish would have listened to me and gone down the 3D printing route, but they didn't. It was a product that won the Popular Science Design Innovation of the Year Award. It was featured on a show called Everyday Edison, so I don't know if any of you have seen that. It's basically it's like I don't know, one of the singing shows or whatever, where they have auditions and stuff. And this guy invented this amazing hand, and he has patents on the mechanisms. But yet, at the end of this project, it didn't move forward because the estimations were that it was going to cost somewhere between $700,000 and $900,000 in tooling costs, in preparation to bring this product to market. So there goes your low-cost hand. I mean, that just went right out the window. Okay, so then on the far end of the spectrum is, and Dr. Chi already showed you some of the other stuff we're doing locally, but this is where it's headed. There's research being done right now on this, where the devices will be directly connected to the person's skeleton through osseointegration. There will be surgical implants or wireless implants to the nerves, so that as a person thinks about doing a task, just like you would now, it'll send those signals down to that device, and it will do that task. But the great thing about it, and there's a great project on sensory feedback, it'll send the information back to the user about what is going on. So are we to that basketball player yet? No, but we're headed there. Believe me, we are headed there. Last quote I'll leave you with, Walt Disney. If you can dream it, you can do it. And thank you. If you have any questions, you can catch me. Well, we're supposed to have a booth. We have a tabletop because our booth is somewhere in the transit and UPS or something like that. So, but we'll be hanging out there later. Thank you.